Hello everyone. In this video we are going to talk about some of the basic set operations that we can perform. So in order to talk about these, we want to first talk about the universal set. So in general you can express a lot of these things with a Venn diagram. So we're going to let A and B be sets. And so you have your typical kind of Venn diagram here. And what we're going to assume is that these are sets that lie inside some bigger universe. So a lot of times, you might be the real numbers, the integers, something like that is just kind of a natural set that you want to consider, right? So, if you're talking about the evens and the odds as your two sets, then you're likely thinking of this inside the integers, right? Because even and odd numbers are always integers. And so this is just some set where all of the other sets you're considering and talking about reside. So the first set operation we're going to talk about is the intersection. So we write this A intersect B. And in this case, these are exactly the elements which are common to both A and B. So in our little picture here inside our universal set U, this is the intersection, the things that both A and B share. And we can write this in set builder notation as, so the elements in our universal set, such that, what's the condition? They have to lie in both. So we say X is in A and X is in B. So let's look at an example here. So I have A as the even integers and B as all real numbers between 0 and 10, including 0 but not 10. So I could also have just written, right, this half closed interval from 0 to 10. So here our U would probably be the real numbers, right? Because B considers all real numbers inside that, not just the integers. While A is the integers, you want to make sure everything's included. And so what would our intersection be? Well, I look inside this interval from 0 to 10, and I'm picking out the even integers, right? Because it's got to be both in A and in B. So it's in this interval, and it's an even integer. So I've got 0, 2, 4, 6, and 8. And so that would be my intersection in this case. So next up is the union. So this is very similarly written. So it's a cup or a U as opposed to kind of like almost an N shape. So you just flip that upside down. So this is the union, and these are the elements that are in A or B as opposed to A and B like the intersection. And so here, A or B, it's just everything inside these two circles, okay? And we can write it in set builder notation in a very similar way, right? So it's the X that are in U, our universe, such that X is in A or X is in B. So let's look at two different examples here. So on the left, I've got A as the even numbers, B as the odd numbers inside the universe of all integers. So if I take the union, this means all things that are even or odd. Well, that's just going to be all the integers, right? Because every integer has got to be one of them. It's got to be even or it's got to be odd. So there the union would be all of the integers, or U itself in that case. And on the right here, I've got a couple of sets, and U is just the set of integers between 1 and 6. So if I look for A union B here, I'm looking for things that are in A or B. So I basically just count off the ones in each. So 1, 2, 3. Again, I don't have repeats in sets, so I don't need to write 2 twice. And then I get 4 and 6. So I'm only missing 5 there because it's not in either of them. So next up is the set difference. So here we can write A minus B. So these are the elements that are in A, but not in B. Okay, so we're in A, but not in the intersection. It's not also in B. So here it's just this side, not including the shared elements. And so we can write this, again, inside our universe U, such that X is in A and X is not in B. Okay, so it's got to satisfy both of those things. Must be an element of A, must not be an element of B. So let's actually look back at that same example we just had here. So A is 1, 2, 3, B is 2, 4, 6. So if I look for A minus B, then I am looking for the things in A, so 1, 2, and 3, that are not in B. So I kind of single out this 2, right? That is in B, so I want to remove that. And so it's just 1 and 3, the elements of A that are not in B. Now I could also do B minus A here, right? So these are the elements of B that are not in A. So I start with 2, 4, 6, and then I look for anything that's also in A. That would be 2. Right? And so it's just 4 and 6 that are in B, but not A. So the last one we're going to talk about here is the complement. So thus far, the universal set really hasn't been that useful. All of the sets have been in, or all of the elements we've talked about have been inside there, but it hasn't really been crucial to the definition because it really just relied on A and B. Here, that's not the case. So the complement, if I write this, so we write A prime, these are the elements that are in the universal set, but not in A. So it's basically everything but the stuff in A. So here, I just basically fill in all of my stuff that's not inside A, right? So we want to be careful to leave out that intersection, even though that stuff's in B, it's also in A. So we leave that out. So it's everything, but you see that open circle there for A. And so this is X is in U, and X is not in A is the condition. Okay, you could also write this using the set difference, right? This is exactly the set U minus the set A, the set of elements in U that are not in A. All right, so let's look at a few examples here. So for U prime, so the things that are not in the universal set, this would be the empty set, right? Because you're in that universe, but you're also not in that universe, and there's nothing that satisfies that. On the other hand, right, what is the empty set's complement? Well, that's everything not in the empty set, but nothing's in the empty set. So that's actually just everything. So that's your whole universal set. And then let's look at some examples with, more concrete sets. So if U is the integers and A is the evens, well, what are integers that are not even? That would exactly be the odds. And this last example, we have U is just the integers between 1 and 6. A is 1, 2, and 3. So the elements of U that are not in A, that would be 4, 5, and 6. All right, so let's look at one more example here, just trying to put some of these things together, and in some cases actually combining a couple. So U is all the integers between 1 and 10, and A are these subsets, right? So for A intersect B here, I'm looking for the things common to A and B, right? So A and B share 4 and 7, and so this is just going to be 4 and 7. For A union B, these are the things that lie in either, right? And so you can just kind of start looking, okay, we have 1, 2, 3 is in B, 4, 5, 6, 7, and then 8 is in A, so we're just missing 9 and 10. So this is everything up through 8. So then what is the complement of the union? Well, we just wrote out the union, and so it's just the other numbers up through 10, not in that set. This is going to be 9 and 10. For A complement, we're looking for the numbers not in A, but in U, right? And so we're missing 3, 5, 6, 9, and 10. For A minus B, we take the set A, and then we take away the things that are also in B, right? So we're taking away the things in the intersection. So 1, 2, 4, 7, and 8, but not 4 and 7. So this is 1, 2, and 8. And again, we can do the same thing, but the other way, right? So the things in B, but not in A. So this time we're looking down here, 3 through 7, but not 4 and 7. And so this is 3, 5, and 6. And so to close things out, I want you to complete this exercise. So you've got the universal set here, subsets A and B, and I want you to find these 8 sets performed or found by using these operations. Thank you for watching.